Thank you all for joining today, and feel free to introduce yourself if you're on Zoom, and if you're watching us on.
There are shy people around. I seem to be dangerous and very threatening. I can totally get that. So no one needs to feel stressed out about that.
Yeah, I think we have made the meetup to like by default mute everyone. So I can always unmute all. I'm going to do that.
I still think it's me looking.
Yep, we have initial 5 minutes. Feel free to introduce yourself, and then we can get started.
Okay, I guess if no one is going, I'll go. Hi, everyone. My name is Taylor. I'm currently working as a solution architect. I'm actually working with Jan-Niklas since
Spoiler.
yeah, and I had to laugh because Jan-Niklas said that he's looking mean, and yeah, I actually got to hear that from a couple of people in the weekend that I definitely look mean. So yeah, that's why I had to laugh. Yeah, it reminded a bit of, yeah, it's really great. Thank you for having the presentation. I'm really looking forward to it.
Yeah, you say that now. Wait for it.
Yeah, I think we could get started, Jan.
Oh yeah. Okay.
Yeah.
Sure. Sounds good. So you can also already see my screen, right?
Like yeah, I'm able to see your screen.
Okay. I was aware of that. That was just a test. So yeah, welcome everyone to my talk, Demystifying RxJS Operators. I'm very happy to do this talk at this online meeting. And within this talk, we will cover a lot about the internals of RxJS to talk a little bit more about the operators of RxJS, because what was important for me to clarify with this talk, many people are already using operators, right? So in the daily work, especially when you're using Angular or whatever, operators are kind of known, but barely anyone really knows how they are implemented internally and how this piece of code is actually working under the hood. And my presenter is not working. Oh, there we go. So to do this, we first need to clarify what an operator actually is. And like a professional that I am, obviously, the first way to deal with those issues is asking Wikipedia. And when I Google Wikipedia for operator, it said it's generally a mapping that acts on elements of a space to produce elements of another space. This is kind of mathematical, but it still describes what an operator is in some way. So it is applying something on something to produce something else. That's pretty much it. Two more words about me before we dive super deep into that. So my name is Jan-Niklas Wortmann. Since last week, apparently, I'm a consultant at Evora IT. I'm a member of the RxJS Core Team since mid of 2018, I think, something like that. Within the core team, I'm mainly responsible for the docs. So if you have any suggestions about that, feedback, feel free to reach out to me via email or Twitter, which is for some reason not on this slide, but on all the other slides. Yeah. one more word before we really dive into the topic itself. So the thing is, with this talk, some of the information that I give to you are heavily implementation detail, and therefore technically it's not a publicly exposed API, which means if you want to build some feature on that, on some of these internals, this could technically break. I still like to do this talk to show you how it currently is, to emphasize and to show you how operators are implemented. Okay, so this is pretty much how an operator or operators implemented. These are the three important interfaces that are defined within the RxJS Core source code. So first we have the unary function. This is more of a helper. It's not very often used. It just defines a function that returns a function, which takes a source parameter and returns some value. This unary function is used within the operator function, which is a unary function just applying source observable and an output observable, which means an operator function is a function returning a function which takes a source observable and returning a new observable. On top of that, we also have the monotype operator function, which is pretty much the same. It just defines that the input observable type is the same as the output observable type. So imagine filter, for example, is a monotype operator function because the output value itself is not changed. It just changes the number of emissions, and therefore it doesn't change the value, the type itself. So let's come back to the this was very technical, looking at code interfaces. I want to take a step back to talk more about the behavior of operators. And right now we are working on a glossary for the RxJS code base, but besides that, so far there's no official definition what we call an operator. From my point of view, an operator needs to fulfill these two criteria. It needs to be composable and it needs to add some kind of behavior. What does that mean? So this is best shown by taking a look at some examples, what I would call an operator and what I would not call an operator. The best example for an operator is actually the map operator. It takes a projection function, which is applied on a source observable and returns a new observable of a different type according to that projection function. From my point of view, from is not an operator. So from is not an operator because it is not applied on an existing observable. It creates a new observable, but it doesn't add behavior to an existing observable. Multicast is more of a special kind because this is actually a little bit tricky. There is one signature for multicast, which is shown here on this slide, which just takes a subject instance as reference, which is used under the hood for the multicasting behavior. The thing here is that this returns a connectable observable, and this connectable observable is used to imperatively subscribe or to make the subject subscribe to the source observable. Therefore, because it doesn't return a connectable observable, this is not composable. You can't call pipe on that. This has to be the last operator in your pipe, or you have to do some additional casting or whatever. There's another signature which takes a selector function, and this is pretty much where the multicasting takes place in. So there's the past observable instance, and this is where multicasting is happening. Therefore, this also turns an observable. Observed value of is some kind of tweak within the RxJS code base, but I promise you it's still an observable. And therefore, this signature is composable and you can consider it an operator. To be fair, we will consider also moving multicast out of the RxJS operators package, because then this would be very clear that everything that is in the RxJS operators package could be considered an operator. There are 2 or 3 other edge cases like this, where things that are in the operators packages are not an operator. So to sum this up, there are 6 responsibilities that an operator needs to fulfill. There's first the handling of all the emissions, like next arrow complete. So even though you might not notice that when using map, for example, and there's an arrow thrown, map for sure doesn't do anything with the arrow emission, but it still forwards that arrow emission to the next operator so that this one can take care of that. The same goes for sure for complete. Barely unknown fact is actually due to the reason that all the operators are creating new observables. For sure, every operator has to subscribe to its source observable. Therefore, it needs to handle the subscription and the unsubscription of this source observable. And the very last thing, it has to return a new observable. So with RxJS 5.5, actually, we introduced this pipe architecture thingy. And this pipe architecture, we still remember that we had the operator function before, describing a source function, taking a observable and returning a new observable. If we fully understand this piece of function code, then we can completely write the observable pipe on the left side using from, map to, and tab, like I show on the right side, where we invert the calls. Because what we do is we take the source observable and return a new observable, and therefore we can always pass the source to the function, and therefore it's inverted. So this inversion of the actual function call happens by leveraging the pipe function. This pipe function, this is a slightly reduced pipe function, which is extracted at least from the RxJS code base. There are some minor performance tweaks, but from a general point of view, this is pretty much what's in the code base. So it takes an area of operator functions, and then it performs reduce on that, just to take the value of the first function and pass the result to the next function. This is pretty much what's happening within the pipe to get rid of this function call invertation. Yes. This is pretty much all the pipe architecture is about. This piece of code came with three big benefits. And the biggest one, and this was also the main reason why we introduced that, was tree checkability. Before we had that, we had the prototype packaging where you were importing map operator, for example, which adds the map function to the global observable prototype. The thing is, tools like Webpack, Rollup, whatever's out there else, are not able to figure out if such a map function is not used afterwards. The way static code analysis works is not working with this kind of imports. Therefore, if you added map once and never used it afterwards, it was still in the bundle size. Therefore, the overall bundle size of using RxJS before version 5.5 was in general bigger. The next thing, from my point of view, the operators and the import structure is way clearer now, and therefore the readability is improved. Also by leveraging this functional approach rather than the instance method approach, this also gives some nice benefits that I will come to. We have one last thing, extensibility, showing like writing custom operators, for example, is way easier than it used to be with RxJS 5, for example. So I would like to come back or take a step back to this statement that I used several times within this presentation already. Every operator returns a new observable. So if this is a case, this code stated out here using behavior subject or is subject instance, doesn't really matter which one, and applying an operator on that would ensure that this returns an observable instance and we're good to go. So therefore, we could remove this as observable instance, and we're aware that either switch map or take until, doesn't really matter, will return a new observable instance. This is actually not really true, because if we look at runtime, one step back. So at compile time, the code will say, oh, you're using pipe. The signature says pipe returns an observable. Here you got an observable clearly. At runtime, you will notice this nasty type anonymous subject. And this introduces actually some weird behavior, because at runtime, you have a subject instance in the hand, but at compile time, you kind of have an observable. So you could call next, but you can't without cast. This is kind of weird. The thing is, this is actually the case due to the lift architecture. The lift architecture was introduced with RxJS 5 and was the main feature of RxJS 5, introducing general performance improvements and stuff like that. So the lift architecture consists out of 3 major parts. We have the call of source lift, taking an operator class, and providing an operator subscriber. So source lift, I will make an example how this is pretty much implemented within map, because the map operator is fairly known. And it's also the most straightforward implementation, actually. There are some operators that are way more complex, like especially things like switch map that have inner subscription and stuff like that. So let's take it easy, map. So map, again, takes a projection function, and this projection function is applied to every value emission. Therefore, you can manipulate the value provided by the source observable to create a new observable with a new value stream. So what's happening within the RxJS code base is actually it's calling source lift, shown here in line 2, 4, 5, source lift. And there it applies the map operator, or pass to a new instance of a so-called map operator class. So let's take a look at this lift method. So the lift method, and this is serious, this is exactly the code from the RxJS code base. So it's creating a new observable. On this new observable, it specifies the 2 meta attributes, source and operator, and therefore it returns a new observable, the newly created observable instance. This is also making the former statement, every operator returns a new observable, kind of true again, but we'll come to that. The important part here is observable.operator equals to operator, which is the operator class or instance that we pass to that in the map operator. So the interface for the operator class is called operator, very straightforward, and it specifies one function, a call function. This takes a subscriber and a source and returns a tear down logic. So let's take a look at the map operator implementation. For sure, it implements operator. And within the construction, it takes the arguments that are specific for this very operator. In the call method, then, what we do is we're subscribing to the source observable. Actually, we're returning the subscription, because this is pretty much what a tear down logic is, a subscription. And to the subscribe, we pass an instance of map subscriber. So map subscriber is now kind of weird, besides that the name is kind of weird, but a map subscriber is these roughly 20 lines of code. And this is also just extended to 20 lines of code because we provided a mechanism to specify this argument without any fancy JavaScript magic. So within this map subscriber, the first thing to notice is that it's extending the subscriber class. The subscriber class is taking care that the emissions, next error and complete are at least forwarded, even though it might be the case that this method are not overwritten. So for example, this doesn't override error or complete, therefore those emissions are just forwarded. But if this wouldn't be ensured, afterwards we couldn't ensure that errors are cached and stuff like that. This is pretty much what observable defines, that it always, that if an error happens, that you can catch it if it completes, you can react to that and stuff like that. This is part of the observable specification pretty much. So what the map operator now does, particularly the map subscriber here, is overwriting the next emission to add behavior to this next emission. And as soon as such a value is generated, it will apply the projection function. Do notice the try catch block here, because this function is coming from the outside world from the point of view of RxJS. It's specified by the user. Therefore, it could technically be that there's a null pointer exception or any kind of error could happen. Therefore, we catch that error. And if this happens, we would emit it as an error signal and not forward it just. But if the function works successfully, we just emit the error and bypass it to the next observable. So this is what's happening in the next function here. This still doesn't really explains why calling operators on a subject instance returns an observable. No, returns a subject even though it says it returns an observable. The thing is, this is the observable lift method. Again, just to recap, creating a new observable instance, specifying source and operator values. And one thing that I forgot before, these two meta attributes are actually important in the subscription process later on. So, but in the end, it's returning the observable instance. The thing is, the subject itself creates or provides a lift method itself. And within this lift method, it specifies the anonymous subject or create an anonymous subject, which is kind of like the base class of an observable, even though it's also not really useful. And it's doing pretty much the same, just besides the fact that it doesn't specify the source, because subjects are a little bit different due to its multicasting behavior. And this is the thing. So we are still calling pipe, specifying it's returning an observable, but in this lift method, which is called under the hood within every operator, we say, okay, if the source is, because we're calling source.lift, if source is a subject, then it will return an anonymous subject. And this is first a weird gotcha, and it's also something that we want to get rid of. There are some edge cases in terms of multicasting where this used to make sense. There's actually an open issue, I think, right now that we fix this behavior. Because at first, so in general, I want to stress here that it's definitely not recommended to call any operator directly on a subject instance. What you do is subject instance as observable and apply all the operators you want to. That's the way to go. The thing is, just from the function signature and the public API provided, this is totally valid to do. And there's nothing right now what we are doing to prevent you from doing this. And this lift implementation within the subject class is something that we need to fix. But again, there's an issue, we will work on that. Back to the actual lift architecture, because this has two super cool arguments. So the first one, I actually mentioned it before, it added a lot of performance improvements. So I unfortunately ever worked with RxJS 5, so I've never experienced RxJS before that version. But from what I heard from all the other members in the core team, the performance improvement was huge between version 4 and 5. An additional thing that's provided by this lift architecture is customizability. What does this mean? So actually, this lift method is a way to provide a custom observable instance. Actually, also a custom subject instance. So for example, there's a Svelte subject, extending behavior subject. This is also using lift, even though not really. There's some different use case due to the way Svelte is implementing state management. But within this custom observable, so the code I show here, this is creating a lock observable. And it's wrapping every operator that is passed to through this lift method in a so-called lock operator class instance. And this lock operator instance will lock all the emissions happening. So the code is not super important here right now. It just demonstrates what you can do with that, because you can add behavior to the observable instance, not to the emissions of the observable. This is a fundamental difference here. How this would actually look if you would leverage this kind of code, it would lock out all the values that are happening, every single signal, every value, and where it was actually happening. Don't be confused by this code, because it's stating out do operator for the tab here. If you used RxJS before version 5.5, the tab operator used to be called do, but just to the way, due to the function renaming, we had to rename that, because you can't import do as it's a JavaScript keyword. One more thing that I want to mention here, this is actually your go-to. So if anyone is out there that wants to provide a browser extension, for example, for RxJS, creating marble diagrams on the fly during runtime, this is your hook in point pretty much, where you want to leverage to build this kind of plugin. And this is also the reason why the lift architecture in general will stay. As it's not publicly exposed API, I won't promise that it's staying in the way it is right now, but to some extent it's going to stay. As we're talking about operators now a lot of time, most of the time actually, there's one more topic that I also want to cover within this talk, and this is actually custom operators. So custom operators have there are two fields where you would use, or in scenarios pretty much, and where you would use custom operators. The first one is kind of you want to create a convenient or alias operator, and the other thing is a greenfield operator. So I would like to start with the kind of convenient, because that's actually the way I prefer RxJS operators, and I want to compare it pretty much, because within normal code bases, we're used to doing something like that. So if we have a magic string or some kind of constant value, we assign it to a constant to give it a proper name, make it more readable, stuff like that. To a certain extent, this also goes for functions. So we have some piece of logic that is reused, we wrap it in a function to give it a proper name, make it more accessible, stuff like that. Unfortunately, this is only used to some extent. So I see a lot of reduce statements, for example, and reduce is actually already fairly complicated just the way it's operating. But by adding such an anonymous function in there, this takes at least some time to process, to understand what is happening here. And actually, it's getting crazy for RxJS in some parts. And this is actually code I wrote like by now 6 months ago, maybe. I know it's a year ago by now. But I'm pretty sure it's still running like this in production. And the last time I saw this code, my reaction was pretty much like this. This is just awful. No one besides me is able to understand that. And even I need like several minutes, if not hours, to fully understand everything again. Okay, why did I do this? What is happening here? How was these connected and stuff like that? This is just crazy. And this would be way more better to just give it a proper name. And the funny thing is, a lot of RxJS operators are already using that kind of mechanism. So instead of creating a fancy new operator, it just provides some kind of convenience by giving it a proper name. So for example, the start with operator is just a combination of concat and from. And actually, it's pretty much just a combination of concat, as from is just there to ensure that it's applied to or created an observable instance. The same goes for concat map. Concat map is just a convenience for merge map specifying the concurrency parameter with 1, saying like, okay, there's always just one subscription at the same time on the inner observable, and therefore this has to complete first before we subscribe to the next. share is actually not leveraging the pipe to reduce the bundle size, even though pretty much everyone is using pipe. But share is pretty much just multicasting and ref count. That's it. So you see, this can be done by yourself. This is nothing special that's within the RxJS code base that need internal logic. You can just, this is actually the cool thing of the pipe architecture. It's just functions. You can combine them as you want to. And so, for example, as some kind of not super easy example, but to demonstrate the strength of that, I built this save get operator, because still sometimes there are people confused when to use switch map, when not to use switch map. Do I need to apply catch map on the inner observable or the outer observable? This save get will answer that question. So I need to perform an HTTP get call. So it will use switch map and it would use catch error on the inner observable to ensure that the outer observable stays alive. And you're good to go. You're pretty safe. And this also reduces the code to some extent. It makes the code less error prone. You will face less issues with race conditions. Yeah. The next thing, which is already, to be honest, I think barely used at all. Technically, as long as custom operator provides that shape, returning a function, taking a source observable and returning a new observable, you can pass anything to pipe method, and therefore you can consider it an operator. What I would be really interested in is, what the fuck are you actually doing there? If you say like, okay, within the 100 of operators that are already existing within the RxJS code base, there's nothing that I can use to implement my behavior. I would be super interested to see what you're doing there. And these 100 operators that I now refer to are actually not considering creation operators and stuff like that. So Jesus Christ. Actually, one thing we are rather aiming for than creating new operators is reducing the public API service, because no one is using it. If anyone ever used window when, please reach out to me. And I would happy to meet and drink a beer on my bill. Like, no one is using buffer window when. Jesus Christ. Okay. One thing I would recommend here is, if you want to build your custom operator on a greenfield, like we had the most recent occasion of a custom operator that is proposed to the RxJS core team is switch scan. I already doubt that merge scan is highly used, but switch scan probably even less. So I didn't vote for that proposal. But the thing here is, this is fairly difficult to implement on your own, as it's complex logic. And therefore, we agreed on having that operator, even though there's still some parts missing. So if you're running in such a situation where you say, okay, there's no operator within those hundreds of operators that I can use to build my super special fancy function, I can recommend you this talk of Ben and Tracy from last year's NGConf. They are going through the steps pretty much in detail, what you need to consider, what you need to prevent. It's pretty much from a story, what kind of things we went through, and what were our learnings. So like the thing I mentioned before with the try catch, this is one of the things that you need to consider. Like, if you provide so general API, consider someone is doing something bullshitty and therefore errors are happening. This is pretty much all I got. So the slides are available here. There's a QR code, even though it's kind of silly to sit right in front of the monitor and scan this QR code. You can also use this bit.ly link with RxJS-operators. So I will also update the slides probably, because there are still some parts about the internal subscription mechanism that I would like to cover. So if you're interested in that as well, I think you can, in Google, this is a Google document, so I think you can watch something. So if you're interested in that, check it out in some days. What I really want to say at this point of time is thanks a lot for having me. I really appreciate doing these kind of talks. and I'm super happy to be here. This meetup was really well organized. I felt very welcome so far. And if you have any kind of question, I'm available for till here pretty much. And if there's something like a more extended question or something more in detail, you can always also reach out to me on Twitter at Niklas_Wortmann. I'm always happy to help with learning RxJS, having questions, stuff like that. So yeah, thanks a lot.
Thanks, Jan. I think we'll go for questions now.
Sure.
You can feel free to ask your questions to Jan while he's here.
Drinking.
So I think we don't see any questions, Jan, but we know we can always catch you on Twitter if we have any follow-up questions from this meetup. Once again, thank you for speaking with us today, Jan.
It was my pleasure. Thanks for having me.
Yep. Thank you all for attending the meetup. If you have any other questions, you can always find us out on Twitter and get your questions answered. Thank you all.